Hello everyone, in this video I'm going to speak about how we can calculate the pH of a weak acid or base solution. Let's get started. There are some important steps before calculating the pH. First, we need to write a balanced equation to identify if the acid or the base that we have is strong or weak, and to know the ratio between the acid or base and the ions produced. We have here an example. We have here's HCl. The ions that will be produced are H plus and Cl negative. We can see here we have one-way arrow, which is indicating that it is a strong acid, and the more ratio between the acid and the ion produced is 1:1. Another example here, we have here another strong acid. We have one-way arrow, so it's indicating that strong acid, but we have here the more ratio between the acid and the hydrogen ion produced is 1:2. Another example here, this is a weak acid. We can see that we have a reversible arrow. And we have another way to calculate the pH of a weak acid than the strong acid. So we have to be vigilant to the type of the acid that we are speaking about. The more ratio is 1:1. Also for the bases, as you can see here, we have BaOH2. It is producing 2OH negative, which is indicating that we have the more ratio is 1:2. And this is a strong base because we have one-way arrow. We have here an example, a very famous example for the weak base, which is the dissociation of ammonia. We have also to remember that the most common weak acid is ammonia and its family, which are like methylamine, ethylamine, propylamine, are from the ammonia family, as we will see in the example later. So we have here the ammonia NH3 plus H2O is producing NH4 plus OH negative. The more ratio is 1:1, but this is a weak base dissociation. So this is the first step, is to write a balanced equation. Next step is to find H positive. As we said before, pH, to find pH, we have to find H positive. We have to find the concentration of H positive. So here we have two scenarios. First scenario, if we have strong acid or base. If we have strong acid or base, we can calculate the pH using negative log H positive if we have an acid. If we have a base, we can calculate pOH first from the concentration of OH negative. Then we can find the pH using this formula. pH plus pOH is equal to 14. And this is only for strong acids or bases. What if we have weak acid or base? Then here we need to set up the equilibrium chart or Rice chart, as you will see in the next problem. We need to find the concentration of H plus if we are speaking about acid. We can find the concentration of OH negative. If we're speaking about a base, then we can use the expression for Ka or Kb depending on the type of the solution, if it's acidic or basic. For acids, we'll find pH, negative log H positive. For bases, we can find pOH first, then we can find pH using pH plus pOH is equal to 14. Let's check an example. In this problem, we should find the pH value for this concentration of ethylamine. Ethylamine is from the ammonia family, so it is a weak base. Given that a Kb value is 5.37 by 10 to the power negative 4. The first step, as we agreed from a while, we need to write a balanced equation to identify the strength of the base that we have here. It is a weak base dissociation, and also to check the more ratio. More ratio is 1:1. Then we can write the Kb expression, which is the concentration of the products to the power of their coefficients over the concentration of the reactants to the power of their coefficient. We will not include water because we are using diluted solutions. So we have lots of water, so we should not include this water. Okay, next step is to set up Rice chart. As you can see here, the ratio is 1:1. the initial concentration is given the problem 0.05 for the ethylamine, and the concentration of the products at the beginning of the reaction are of course 0. Then the change is negative X to the reactants and positive X to the products because they have the same mole ratio. Then at equilibrium, we have the concentration of the reactant is 0.05 minus X, and for the products X and X. This X is very small and it could be neglected. Why is that? Because Kb is small. When Kb is small, so it means that we have a very small amount of ions will be produced. So we can, with any problem like that, we can also assume that this X is negligible, or it could be disregarded because we have small Kb or even Ka if we are speaking about weak acid. Okay, we'll put the numbers in the formula. So we will have in this formula, of course, then we will have his Kb's given the problem. Then we have X and X concentration of the products. Of course, they will make X square. Then we can find X. X is equivalent or equal to the concentration of OH negative. Then we can, of course, find POH, which is negative log OH negative, 2.3. Then pH is equal to 14 minus POH, so it is equal to 11.7.